Assalamu alaikum. We are discussing questions, paper 2 questions on work power energy, and इससे पहले भी हमारी कुछ क्लासेस इस पे हो चुकी हैं. W is equal to FD. What is meant by work done? Work is equal to force into displacement. A boy on a board B slides down a slope as shown. Work की definition क्या है? Work is the product of the force and the displacement in the direction of the force. मैंने पहले एक्सिस बनाया है. मैंने इसमें पहले एक्सिस बनाया है. इंक्लाइन प्लेन पे ये कॉमन प्रैक्टिस होती है और अक्सर रेजोल्यूशन की जरूरत पड़ रही होती है. तो मैंने पहले ना इसमें the angle of the slope to the horizontal is 30. The total resistive force acting on B is constant. Assalamu alaikum. Ali, can you hear me?
जी वालेकुम अस्सलाम. I can hear you.
Okay. We are doing some questions on work, energy, and power as our plan for doing some work on paper 2 topics from the start of the syllabus. And you can see this question, June 14, 23-3. The first is the definition of work done. Work is the product of the force and the direction, force and the displacement in the force and the distance in the direction of the force. Second part is an inclined plane. A boy on a board B slides down a slope. The angle of the slope is 30. The total resistive force acting, वो मैंने show की है. आप भी diagram में से share कर लो. State a word equation that links the work done by the force on B to the changes in potential and kinetic. अब ये नीचे आ रहा है तो potential कम हो रही होगी, kinetic बढ़ रही होगी और work done against friction होगा. तो आप क्या लिखोगे? Loss in EP is equal to gain in EK plus work against ये इक्वेशन बनेगी, वर्ड इक्वेशन. The boy on the board moves with velocity v down the slope. The variation with time of the velocity is shown. Velocity is increasing at a constant rate. The total mass of B is 75. From B, t is equal to 0 to 2, t is equal to 2.5. Show that the distance moved down the slope is 9.3. अगर velocity time graph है, तो उसका जो डिस्टेंस होगा वो होगा एरिया। ये कह रहे हैं 2.5 तक जाएं। देखो, अब ये नंबर रीड करना पड़ेगा कि ये y पर ये नंबर कहां तक रीड हो रहा है। 6 है और बिल्कुल बीच में अगर मार्क करता हूं तो 7 है, तो मुझे लग रहा है 7.4 है ये। So we can say, we can check it here. I think it's 7.4. So we can make a triangle because we need to find the distance, and area of a triangle can help us out here. This is the 2.5 and 7.4. Calculate the gain in kinetic energy. Distance निकल आएगा, and you can find this number for me. If you can get this number for me.
It's 9.25.
9.25. Okay, and then how we find the gain in kinetic energy?
By the half mv square.
Right, this is the right approach. Gain is half mv square. But we have, they haven't given us, we can find the velocity from the graph. Initial is looking 0 and final is looking 7.4.
So mass will be taken 75 and then do it.
Yes. The mass, total mass is 75. Now see this.
It is coming as 2053.
2053. 2053.
Yes.
4 sig fix. So I can write it as 2100. Calculate the loss in potential energy. Formula is there. Delta EP is equal to mg delta H. Now we have a triangle and we can find the height using trigonometry, but we don't have the distance. No, we have the distance, right? Yes, we have the distance. How much distance we got? Sorry, 9 point.
9.3.
Okay. So we have the distance and we should make a triangle for examiner understanding, convincing the examiner. Nine 9.3. This is the height. This is 3. Now I have shown the working and I have made a triangle also.
9.3 as the direct height cannot be taken.
No, because 9.3 is not the height. 9.3 is the distance on the slope.
Now it's coming 4.65.
Then we know the loss in potential, which is 4.65. We know
So
the
4.5
loss.
was for the sine 30 into
Oh,
9.3.
acha, I'm so sorry. It's not the final answer. It's 4.7 is the, okay, fine. What you can get the final answer? 2053 is the kinetic energy.
Final answer is 3400 joules.
So 3400 is here and 2053 is kinetic. Work done is force into displacement. Force we need to find, and distance is our distance was 9.3. So you can solve it. How much is 3400 minus 2053?
It is 1347. It is coming as 144.8.
Rounding to 2 sig fig, we can make it 150. We are putting June 14, 224. Explain what is meant by gravitational potential energy and kinetic energy. Gravitational potential energy is the energy possessed by an object due to its position in a gravitational field. And kinetic energy is the energy possessed by an object due to its motion. So these are the two well-known definitions. Then he has involved projectile. A ball of mass 400 grams is thrown with an initial velocity of 30 and an angle of 45. The resistance is negligible. The ball reaches a maximum height after a time of 2.16 seconds. Calculate the initial kinetic energy of the ball. I have shown the formula and the working.
It's 180 joule.
The maximum height of the ball. This is again a type of concept which should be remembered, that in a projectile motion, there are always two velocities. When it reaches the topmost point, it's only the horizontal component at the highest position. The vertical component of velocity is 0. So we have the data now, and we should be considering first half motion. So for the first half motion, if I consider the first half, it will be minus g. So I have all the data in my hand. The initial velocity, I will taking the u. U is equal to v sine theta, which means 30 sine 45. Now, I have made all the data. I have U, I have V, so I should take 2AS is equal to so you have to put the values. Acha, we have time also. Sorry. Then we could have used S is equal to UT plus half AT square. Anyways, we have brought it up to here. So you can try this value.
I'm getting 23 meters.
Are you rounding it?
Yes, well, otherwise I'm getting 22.93.
Good. But always show the examiner the number before rounding, and then you should round it. That will be an easy way to show the examiner that you are doing rounding on purpose. The gravitational potential energy of the ball is height h. Now we have the height and we have the mass, 400 gram.
I'm getting 89.97.
89.97. Determine the kinetic energy of the ball at its maximum height.
Won't it be zero?
No. It won't be zero because the object has not stopped. Its only vertical component has stopped, but horizontal component is still live. So its kinetic energy is due to its vertical component. Let's see
Won't
how.
it be? I took 30 cos 45.
Oh, acha, so sorry. I took 30. It's not 30. The angle is 45.
The previous question, like you were taking 45.
Angle is 45. Now I took by mistake 30 here. You're right. So first you solve this.
It is coming as 21.2.
What?
The 30 cos 45.
21.2.
Yes. And final answer is coming as 4.24.
Eh? 4.24. How it can be so small?
I
4.
forgot to square the 21.2. Oh, I have to
Sorry.
square. I forgot to square the 21.2.
Hmm.
It's 89.88.
Right. Explain why the kinetic energy of the ball at maximum height is not zero. Why it's not zero? Because it's not zero because the horizontal component is not zero. It's still driving the ball, and so it's not zero. And another way of solving this part of the question is the idea that he had asked to calculate the initial kinetic energy, the launched one. And then we know the potential. When the ball is going upward, there will be a loss in kinetic and gain in potential. So we can also do it by subtracting the initial kinetic and the potential. We can also get the same answer by the approach. Now it is November 14. A motor is used to move bricks vertically upward as shown. The bricks start from rest and accelerate for 2 seconds. The bricks then travel at a constant speed of 0.64 for 25 seconds. Finally, the bricks are brought to rest in a further 3 seconds. The bricks start from rest and accelerate for 2 seconds. The bricks then travel at a constant speed. This is a bit story type question. For the first 2 seconds, so it looks to be a story that the object started from zero and then accelerate for 2 seconds. The bricks then travel. He says the change in kinetic energy of the bricks. And then it stopped at 3 seconds. So if I roughly imagine a sketch for my understanding, so it looks to be a shape like this. I made this graph to get my understanding that how it's moving. So I have made this diagram. Now I have a picture that how this brick structure is moving. Now he says that finally the bricks are brought to rest in a further 3 seconds. No, the sketch is not right. First acceleration is for 2 seconds. The bricks then travel at a constant speed of 25 and then stop. So I need to correct it. He says that for 2 seconds, for the first 2 seconds, and then for the first 2 seconds, there is an acceleration for the first 2 seconds. And then it travels for 25 seconds. And then it's brought to rest in 3 seconds. Now this is a better picture. And now we can have a clear idea what the examiner is discussing. So I made this picture. Now he says, examiner, in the first 2 seconds, the change in kinetic energy. So I have a database here now, delta EK. Now you have see this calculation.
It is coming as 5.1 joules.
In the next 25, if we see the next 25, which is this portion, 25 seconds, this portion. He says determine the change. You can see that it's a horizontal line.
It will be 0.
Yes. The final 3 seconds, 0.642 ground back. It's the same basically size, and only the difference would be there. Here it's a gain because speed is increasing, but for this it will be in the same value because the change in velocity is the same. But this time it will be a loss. Why should I say loss?
Because its speed is decreasing.
Because there is a decrease in speed, right? The bricks are in a container. The weight of the container and the bricks is 350. Calculate for the lifting of the bricks and container when traveling at constant speed. Calculate for the lifting of the bricks and container the gain in potential energy. This is the portion when it is moving at a straight line. Velocity is constant and still it's going upward. So we have the formula mg delta h. How we can find the height? It's moving at a constant speed. You can find this area 25 for 25 seconds. So can you tell me how I can find the height when it's moving at constant speed?
Area under graph.
Yes, and it's a straight rectangle, and I can tell examiner in another way because I have drawn graph for my own idea. This is the place where I can find the area. It's a rectangle because speed is constant. So when speed is constant, distance is equal to velocity into time. They have given us the weight. Can you get the height?
It's coming 16.
16. You said 16, right?
Yes, so we will ignore the acceleration part in this. Then only take
Because
the
he
constant.
says, look, the question, calculate for the lifting of the bricks and container when traveling at constant speed. So we
If
need to
it's
find,
whole journey, then you take the.
yes. He's not involving the whole journey. That is why we are taking only the straight line part.
It is coming as 5600 joule.
Are you rounding it already?
No, this is the answer.
Oh, that's good. The power required. Now, power is the work upon time. Power is equal to FV. Both can be done. It's moving at constant velocity. So we can use power is equal to FV. Force would be equal to weight because speed is constant.
It is coming as 224.
24. I have taken correct to 2 sig fig. Define power. Power is the rate of doing work. It's basically work upon time. Figure 3.1 shows a car traveling at a speed of 22 on a horizontal road. A car has a mass of this, a resistive force 1200 Newton acting on the car. The force F required for the car to produce an acceleration of 0.82. This is supposed to be the car. 1200 is opposing. Resultant force is equal to MA.
This is coming as 1230. So we'll minus the 1230 with 1200.
Sorry.
We will minus the 1230. This answer with 1200.
But how then it would be a 30 answer only. How 30 can be the answer?
Because wasn't the resultant force is equal to greater force minus smaller force?
That's right. F minus 1200. So 1200 will come and add there. Na?
Yes, that will add.
How much force you are getting?
2430.
Power, he says, the power required to produce this acceleration, power is equal to force into velocity. So you put this formula.
It is coming as 5.346 into 10 power 3.
5.346. So I will take it 5 point. I'm taking it 3 significant figure. Then examiner says the resistive force on the car is proportional to V square, where V is the speed of the car. Why the car has a maximum speed? The concept of maximum speed actually means in our term the famous topic terminal velocity. So you will tell the examiner that this happens when the driving force equals the resistive force. When the driving force equals the resistive force, the velocity will become terminal. An object is moved from point P to point R either by a direct path or by the path P to Q to R. P and Q are on the same horizontal level. R is vertically above Q. Explain whether the work done moving the object against the gravitational field is the same or different along path PR and PQR. Potential energy depends upon height. Height is the same. Height is the same, so the change in potential energy will also be the same. So you will tell the examiner that the work done moving the object against gravitational field will be the same because the height is the same. A ball is thrown with an initial velocity v at an angle theta to the horizontal. The variation with time of the height of the ball as shown. Height is increasing with time and then reaches the maximum height and then comes down. Use the time to reach maximum height to determine the vertical component of the velocity of the ball for time t is equal to 0. We can get the maximum height from the graph. I marked this line here. I think it is 11 because it's coming in between 10 and 12. Height is 11. So you know that at the maximum height, whatever the maximum height, the vertical component will be 0 at the maximum height. So I'm thinking to first show a resolution here. This is U and this is V. So now I can build my data. I have sufficient information in my hand. So I can take this is the vertical component I need to find. I can get the time of the maximum height from here. You can get the time from the for the maximum height. It's coming in between. So it means it will be 1.5. So I have the time now. So I have collected all the data in one position. And now I have to select a formula. What formula should I select? Yes, Ali, can you tell me the formula?
V is equal U plus 80.
Right.
We can also use 2as that formula. 2as is equal V square minus U square.
Because I have U, but I don't have, but I need to find actually, I need to find U.
U. And then S is equal U2 plus half 80 square is better.
Why not try this one?
I think all of them can work.
This is interesting. We need to find to remove the square by taking under root.
It is coming as 14.7 VY.
14.7. The horizontal displacement of the ball at t is equal to 3 is 25.5. The horizontal displacement of the ball at t is equal to 3 is 25.5. The full distance actually. And they have given us the horizontal displacement. So horizontal displacement should keep on increasing, and there is no acceleration in horizontal dimension. So I think we should draw a straight line because horizontal distance is occurring without any change in velocity. There is no velocity. There is no acceleration in so it means when I draw the actual sketch, for the ball at maximum height, calculate the ratio of potential energy of the ball, kinetic energy of the ball. So you have to make a ratio for that. Have we found the potential energy already? No. As I'm making a ratio, I can cancel mass, move the two up. Now, what is the velocity at the highest position? We don't have the velocity, so we have to get it out because the horizontal velocity remains constant. Now, can you help me in finding how I can put? The problem is now I'm here because I need the velocity. There is no vertical component at maximum speed. Only horizontal component.
So will we use the 22 in this as well?
22. 22. What 22?
Like this, the x over t, the displacement over time.
I'm thinking about this is 25. You're right because you are right because I can get the velocity from here because it's a straight line gradient. How much is 25 upon 3?
It's 8.5. The 11 was the maximum height.
Yes.
It's coming as 2.98.
The ratio is coming 3. This is that in practice, air resistance is not negligible. State and explain the effect of air resistance on the time taken for the ball to reach maximum height. So air resistance will dissipate energy against resistance. So the resultant force is greater. So overall time will less because it will reach less height. Due to air resistance, maximum height won't be 11. It will be less than 11. So the time will be less. So we keep it up to here and we do it in our next class. We have, I think, 2 holidays, maybe maximum for Eid, and inshallah, I will be starting back. So we'll be doing, inshallah, more work on the same chapter. So it's over for today. Allah Hafiz.
Allah Hafiz.